Hello friends, welcome again on AVM IT Lab. I hope the day one video was informative for you and you liked the video. Let us start our learning day 2. Please share your feedback in comment after you watch the video. Thank you so much. Here we go.
Hello friends, hope you all are safe and doing well. We are back with our day 2 video which is going to focus more on VNF and NFV part. VNF means virtual network function and function virtualization. As such, there is no prerequisite for this day 2 video, but I would appreciate if you have gone through the previous video, which is our day 1 video. In that, you're going to understand what is SDN and what are different SDN principles. So when I'm going to explain things about VNF and NFV, you would be able to connect the things in a better way. So please go through my day 1 video first before playing this one. So let's start with the topics and introduction. So in this video, we will focus on virtual network function and NFV, how they are different from each other. We will also look into the fact that how VNF and NFV are closely following SDN principles to deliver a service. At the end of this video, we will focus on our last slide, which will tell you the benefits. What is the benefit after following this new approach, and what were the outcomes, or you can say factors which pushed us to go towards this approach. So let's start now. When we say VNF, VNF is basically a virtual network function, which I can explain you better if I open a MS Paint and draw a small diagram. See, I'm just picking a very basic example, which is like from our day-to-day work. Since we all are working in networking, or we are somewhere related to networking field, so we all have heard about a router. What is a router? A router is something which works at layer 3. That is the basic definition everyone knows. When we say what is a switch, everyone says, yeah, it's something which works at layer 2. But if you have heard about some CPE architecture, you can correlate this example with a CPE. In general, what happens if we are delivering a service to a customer? That customer is having his LAN somewhere connected behind the CE router. Okay, so this is your CE and this is your PE. Between CEP, we usually have a connectivity over which we can run any IGP protocol, we can run BGP, we can run static routing. Okay, and in the configuration of C, we usually do a different, or you can say we utilize different features like QoS, okay, L2 routing, or L2 switching, or L3 routing. Okay, in between this circuit, we can use static routing or BGP or any IGP. So when I'm saying that an IGP is running between my CE and PE, it means there are some softwares or software functions which are running inside this physical box, and those functions are capable of understanding this specific technology. So if I say that my CE is having an IP address of .1, let's say 192.168.1.1, and PE is having an IP address of .2, and they are making a BGP neighborship with each other, which means both the CE hardware and PE hardware is running a process inside it which is capable of understanding this BGP protocol and can make use of this protocol to make a peering with the PE router. On top of that peering, this CE is advertising the prefixes which it is learning from the LAN and also receiving the prefixes which it is receiving from the remote end, which means PE router. Now these all processes, these all functions which are running inside this CE router are kind of dependent on the hardware, which means if this CE router is provided by Cisco, you are forced to run an iOS software provided by Cisco, or iOS XE or iOS XR provided by Cisco only inside this CE hardware. Similarly, if you are having a PE provided by Juniper, and whatever processes running inside are dependent on version of Junos running inside it. You cannot uh, extract the software part of this CE router and install inside a Junos router. You cannot do that because those software images are dependent on this hardware. But that software image is somewhere facilitating different functions inside, like BGP function, QoS function, L2 understanding, L3 routing. Okay, and there are many. These are just basic examples. Okay, now when you are moving all these software dependent functions out of the CE router and installing them inside a virtual machine, which is for sure running on top of some hypervisor, could be a vCenter or could be KVM or could be anything, whosoever is capable of giving a virtual machine, then we call that virtual machine a virtual network function. But in general, that router or that switch is a group of different small functions which were earlier running inside the CE router, and now they are running inside a virtual image. And those functions are not dependent on hardware anymore, which means you can bring a Dell server or you can bring a HP server. Okay, on top of this Dell server or HP server, you install a hypervisor, which could be ESXi if you are using vCenter. If it's a Linux box, it could be KVM. Okay, and then you make a virtual machine and boot this software image inside that server. So you are no longer dependent on the hardware chassis provided by Cisco. So you are somehow moving away from that limitation which was earlier there with the classical network, that you are dependent on hardware provided by the same vendor, and you are getting the same functionality here. You have a virtual machine which is running inside this server. Okay, you can have more than one virtual machine, and that virtual machine is going to behave exactly same as what a physical machine is behaving here in this topology. And all these small network functions like QoS, okay, L2, L3 functionalities, these all small functions are now virtualized, or you can say moved from this physical machine to a virtual container called virtual machine. So these all small functions become individual virtual network functions, and when you combine all of these network functions together to deliver a service, it is called NFV, network function virtualization. So let's go back to the slide, and this slide is quite self-explanatory because I have written it in a way that it is self-understood. So you can see, like, network function virtualization is a standard framework defined by ETSI that explains how virtual network functions fit into a complete system, including management and orchestration. Virtual network functions are simply defined as the virtual function itself. For example, a virtual firewall, a virtual load balancer. So this second point is going to tell you exactly what I explained you over a slide. The whole machine you can consider as a virtual network function, but in reality, that virtual function is again having different small virtual functions running inside. And those virtual network functions, right, the right word to call a bunch or a tightly coupled set of virtual network functions is NFV, which is network function virtualization. So a VNF can be used in an NFV solution, but are not themselves NFV on their own, which means if I go back to the this my PPT, sorry, not this PPT, it is Paint. Uh, this QoS function, when I'm virtualizing it, it becomes a virtual network function. But you cannot use this virtual network function alone. It's not like that you're gonna put this QoS or L2 virtual network function inside a virtual machine and this gonna give you a specific kind of connectivity. No, you need to combine a lot of different virtual network functions together to make a NFV. Because if I talk about this link, this is a physical link which has capability to send traffic from P to C and from C to P. But this traffic is in the form of signals, or if it is a fiber, it is in form of light. Now you need certain functions running on both sides CE and P to interpret that signals or that light functions into some numeric digits or some digital functions. Now those small functions are also virtualized when you are putting them inside this server in a VNF. Okay. Now the output of those small virtual functions is further forwarded to maybe QoS or maybe an L2 function who is responsible for doing his job. Now, once that job is completed, the output of that virtual network function is again forwarded to L3 network function. If you are using an L3 functionality, since we are talking about BGP, so definitely L3 will come into picture because it is IP header or it is IP based. So one virtual function itself is not capable of delivering a service. But when you combine a bunch of network functions together or virtual network functions together, then you can say that, okay, I have the capability to deliver a service and it is called NFV, network function virtualization. So, excuse me. So here you can see like we have a classical network model of different hardware appliances. You can see in this PPT we have PE routers, we have BRAS, we have carrier grade NAT, we have WAN accelerators, we have CDN devices, we have routers, we have firewalls, and we have DPIs. I mean, a lot of things are there, right? But now with current uh, virtualization, this has moved from physical to logical. They are no longer part of physical hardware. Okay, so VNF is a network functionality provided in the form of virtual machine. It has the same capability to deliver same service, and sometimes these are more powerful as compared to a physical hardware box, because a hardware box is limited in terms of resources. Let's say today you have assigned, or when you are ordering your physical hardware, you have 2 GB of RAM. You have a certain X amount of CPUs inside. After 6 months or 1 year, you have started using your hardware in such a way that that 2 GB RAM is no longer, fulfilling your needs. So you have one option in your hand, that you again go back to your vendor, ask him to provide an upgraded version of the routing processor unit, or maybe the switching processor unit which is running inside your physical hardware, or maybe come up with some new hardware models, and you're gonna need to move from old classical hardware to new classical hardware, maybe a upgraded version of the previous model which is having more RAM and CPUs. But here, if you are running in a virtual machine and currently you are using 2 GB or let's say 5V CPUs, the moment you need to increase it, your underlying physical servers, if you have enough capacity there, okay, you can increase these requirements, or you can say um, resources very quickly. You just need to shut down your virtual machine, allocate more resources to it, and bring it back up, and it will be having 4 GB instead of 2 GB. And this all can be achieved in a very small fraction of time. No need to replace your hardware, no need to put, or order a new hardware. Everything can be achieved just in a fraction of second. And also you can use some orchestration and automation with this kind of network, that you can set certain threshold values, that once you have one of your virtual machine reaching, or using 80% or 90% of the resources, you can probably put some orchestration in place that it gonna build a similar virtual machine which is running parallel to your previous one, and a load balancer service is introduced somewhere in the cloud, so that your traffic is now no longer catered by just one virtual machine, and will be divided among the two virtual machines which are having exactly same software, same application running inside. So this kind of environment you can achieve when you follow this VNF NFV principles, and move from classical network model to new network model, which is based on virtual appliances. So in contrast of what we have discussed in last 10-15 minutes, I gave you some understanding on VNF and NFV. Now it is more important to understand how these VNF and NFVs are following SDN principle. If you remember, in my previous video, I was talking more about centralizing the control plane, okay, which means your physical equipments, or you can say your nodes, physical nodes, which were in the classical model having their individual control plane, management plane, and data plane, no longer remain in that architecture. And we, which means using SDN principle, you are extracting the control plane out of it and putting it at a centralized place. So when you follow the same principle in VNF, NFV using SDN, it is like delivering same service in a different way, or it's like a new way of delivering service. You are no longer following the classical model, and you are following the latest trend of the market, where everything is virtualized and centrally managed. Now NFV, VNF, you already understood the difference between them. So I can simply say that you have the resources, or you have the network services which were earlier installed inside dedicated hardware, are no longer part of those hardwares, and are hosted on virtual machines which are running on top of some x86 service. So when you are following this kind of principle, where you are installing them on top of x86 principles, you need to focus on their management, their control. So we introduced the same SDN principle, okay, and this SDN principle is maintaining, is controlling the virtual machines on x86 service. Okay, those virtual machines could be anything, routers, switches, and all. And with this collaboration, we are expecting new opportunities in terms of network services, that we can offer some innovative services. We can offer services quickly to the market, or quickly to our customer. If a customer is expecting a hardware to be delivered in X amount of time, that can be reduced drastically to x by 10, or maybe x by 30. If you have your infra completely ready, and you can deploy his virtual machine in just a fraction of minutes, then the only thing remains is routing. You need to make sure that you are properly routing customers network to your virtual machines, and delivering him service. So following this principle, you are capable of offering innovative services, plus the time to market is reduced. Also the operational cost, because now you are maintaining, you are controlling your network from a centralized location, and you do not need to go for a new hardware every year or every 2 years, because you are expanding. So your opex and capex has also reduced. The main factor is capex, because earlier if you have to deal with 10 different technologies or 10 different vendors, it means you need to spend on 10 different hardware. Here you can keep all those 10 different hardware virtualized machines, or which means replica of the same hardware running on a virtual machine inside an x86 server. So instead of spending on different vendor based hardware machines, you are just supposed to spend on x86 servers. So your capex has also reduced drastically. This also gives you vendor independence. Like I told you before, Cisco iOS can run only inside Cisco hardware, or iOS XE or iOS XR, anything. I mean, you cannot run on top of Juniper hardware. But now with this concept of VNF, NFV, along with SDN, you can run different virtual machines provided by different vendors on top of a third vendor, which is having expertise in delivering x86 service. These are some definitions or uh, concepts basically which will help you to understand more the collaboration between SDN and NFV. Like I said before, SDN is a separation of control plane and data plane, and you need a centralized controller to control all your network from a single place. And that controller is responsible for uh, defining the traffic path from A end to B end, or maybe from any of the managed hardware box to another hardware box. And another thing is programmability, that these centralized controllers are exposing their APIs, which means they can be controlled from any application or any third party application which supports API. So in a nutshell, SDN is helping you to separate control plane and data plane. It is giving you flexibility to manage your network from a centralized location. Since it is API capable, it is giving you big programmability features, okay, which enhances your network and delivers greater level of flexibility, automation in your network. Now, with NFV, if we try to understand the same concept with NFV, NFV is implementation of the network functions in software, which means you are extracting the same functionality from hardware boxes and you are implementing them directly in the software. And those software run virtual machines are running on top of x86 service. Okay, these servers could be any industry standard hardware provided by Dell, HP, so you do not have a vendor dependence. Okay, so this is an architecture of hosting and connecting virtual machines following SDN principles and delivering the same service as it was delivering before using the physical hardware. But this time the delivery is enhanced, it is quick, it is more effective, and also it is innovative, which means you are not limited to certain old technologies, but you can deliver something new to the market, new to the customer. This software defined network allows you to control your network from a centralized location. So since this is a new terminology, it's a new technology altogether, it has introduced certain new protocols like OpenFlow XMPP. But it's not like that it is bringing everything new to the market. It is also following certain old protocols which are still having a big capability like BGP, okay, and using those protocols to interact with the classical hardware model. So when you are thinking to deploy new SDN network, SDN based network in your enterprise or in your organization, it's not like that you are doing a fresh installation, completely fresh installation, and you are building a fresh network on top of it. It's not like that. It is a expansion of your previous classical network only, but now you are doing a shift in your thinking, because network is not limited to physical, it has moved now to virtual. Now, with this discussion, I mean, whatever we have gone through in last 20-25 minutes, there are some points which will give you understanding about the benefits of keeping SDN and NFV together. Because if you understand NFV, VNF, and if you do not understand SDN, it's of no use. Similarly, if you have a VNF ready and you are just deploying it without following certain principles, it may not going to give you results you are expecting. So there is a standard framework defined by ETSI for NFV and SDN, and everyone is following it. So there are certain points which you can consider as benefits, like you are now flexible to move functionality from hardware to a software component. Okay, instead of getting dependent on your vendors, now you are independent. Okay, you can use your commodity based servers, which means earlier you were using your servers just to host certain applications like mailing servers and all. Now the similar kind of hardware, which is a server earlier hosting just certain applications, can be used to host your virtual machines. Okay, so you can optimally use the same infra, because every environment, every network, every organization is managing servers, and they were also managing physical hardwares for network. But now you can manage both on top of existing servers, or maybe you need to stop purchasing new hardware, which is router or switches, and you can start putting them on top of these servers only. So you just need to focus on one hardware, which is server. x86 server could be provided by any vendor, and you start putting your VNF NFVs on top of it. These all different software components are API enabled. So using those APIs, these can be accessed by any third party application. These can be accessed by any language. If there is an application configured or built in Python, or if there is one application which is built in C++, both of them can access the same third party without making any difference. They are just supposed to use this new software on APIs. Okay, and using this framework, you can also implement automation. You can automate certain actions which you are doing on a daily basis. Just send some API calls to extract that data, because normally I have seen that guys are extracting a lot of reports. So they either go directly into the device, execute certain commands on a daily basis, and then collect that data. Here, since your network is completely API based, you just need to build some automation based scripts. Those automated scripts will run as per your defined schedule and give you that data. Okay, so NFV can provide infrastructure where SDN can run services. SDN can connect NFVs with a seamless end-to-end view. So both SDN and NFV needs to be working together. Then only you can get a very good solution. Okay, so in an SDN and NFV solution, an too expensive physical hardware provided by some hardware vendors is replaced by generic hardware, which is your x86 server. And on top of that, we are putting some advanced softwares fulfilling the same needs, which means we are putting VNF and NFVs on top of it. And if there is some SDN based controllers, we are putting that in terms of software, and that software is managing your network. Okay, the software based control plane can be moved from an expensive location, which is in general a customer is managing that inside his premises, we can move that from there to our means providers infrastructure inside dedicated data centers. Okay, and those data centers can be managed by provider directly and can be accessed by customer and provider both. So we are giving another leverage to our customers that you do not need to maintain your control plane environment. We will take care of it. Okay, so these are certain benefits which are very important when you are delivering a service to your customer. And customers are nowadays, very demanding. They need everything from the provider. So if you have certain good skills or good features in your network which you can provide to your customers, it is going to help you a lot. I hope this video was informative for you and you got a good understanding of VNF, NFV and how VNF, NFV is used with SDN principles. Thank you very much and stay tuned for my next video.